So we're going to take a look at the ambiguous case for a sine law. And this is where you solve your triangle, and there can be more than one type of triangle, or say more than one angle that will work for your triangle, or more than one side length. Okay? And we'll see how that works with an example here. Okay? So I've been given these measurements, okay? And all I did was I created a generic triangle for my shapes up here. Okay? So there's all the different shapes. I just picked one here, drew it out, okay? And just did a random one here. Okay? So I'll take that, make it a little bigger, okay? And then we'll label it. Okay? So maybe we'll make this the B, okay? And so angle B is 48 degrees, okay? My side B is 21. Okay? Then we'll say C and A, and my A length is 25, so we'll put that there. Okay? And that's all the information that I'm given. Okay? So again, I'm asked for angle C here, so that's what they want to know. So there's the angle they want. Okay. But you'll notice I have no side length to go with it, so I'm going to use my sine law, find angle A, and then I can go 180, subtract the two that I have to solve for angle C. So I set up my sine ratio here. Okay. I've got angle B, side B, so I'm definitely using that. I'm going to solve for angle A. So there's the other ratio. So we fill it in. B is 21 over the sine of B, which is 48 degrees, is equal to A. So my side of A is 25 over the sine of A. We cross multiply. So I get 21 times the sine of A is equal to sine 48 times 25. So solving for sine A, I have to divide both sides by 21. Gets rid of that. And we'll throw that into the calculator. So I take the sine of 48, multiply that by 25, divide that answer by 21. Okay. I get, there's my decimal. If you remember from the sine video, right, that's not my angle, that's what the sine of angle A is. And I want to know what actual angle A is. So that's where we do the inverse sine. Okay, so inverse sine of my answer, so I put in my answer here. Enter, okay, and it's telling me it's 62.2 degrees. Okay, so we'll just round that off to 62. Okay, so my angle A equals 62 degrees. Okay, so let's put that in my diagram. Now, a couple of things about this. Okay. This triangle that I made, it gave you a couple of things. It gave you this length of 21, this length of 25, and it gave you an angle. Okay. So let me just group those things together for a second. Group them, and let's just rotate it around here for a second. Left my A out, but that's all right. Okay. So there's my 21 and my 25, they're backwards, so they're upside down now, but that's all right. And there's the angle I was given. Now there's a couple of different possibilities. Okay? There's one of them, okay? But I also could have had this situation. Okay? So here's my imaginary line down here with a base. I could have been given that this line is 25, like this, and then came down as 21, like this, right? So I've got two possibilities for this angle that I solved for. One of them was 62, okay, which fits that diagram, but I made that diagram up. Okay? And then the other possibility right here is a very large angle, okay, compared to 62. This one's going to be much larger. Okay? So, you say, what other angle could there be? Okay? Well, here's where you have to think about what the sine ratio actually means on a grid that goes larger. So let's just take a unit circle and put it on here. And we'll say, okay, let's put a line on here around 62 degrees. And the sine of this 62-degree angle is the opposite here of the hypotenuse. Okay. You might say, well, isn't that the only place where if I had this same hypotenuse, I could get the ratio that I got? Well, no. Over here in this quadrant, I could have the same hypotenuse length. Here's the opposite, and this opposite is the same as this opposite, right? And so this triangle and this angle, which is all the way to here as opposed to here, which the shorter, the smaller one is 62 degrees, this one, okay, is larger. Okay? So you say, well, what is that angle? How far away from zero is that? Notice this is 62, so this angle right here is also 62. So it's 62 degrees away from 180. So this angle, okay, is 180 minus 62, or 118 degrees. Okay. So all you have to do to get the other angle is take the result that your calculator gives you, because your calculator always assumes this first quadrant. Right? This is the first quadrant. The second, if we went all the way around, right, and extended this line, this is the third, and this is the fourth quadrant. Your calculator always assumes that the angle's in this quadrant, okay? But if you take the sine of 118 degrees, it'll give you the same result. So just to show you that that's true, okay, I'll do the sine of 180 minus the 62.2, so that was my previous answer. Okay. Hit enter, and look, I get the same result. Okay. So whether it's 62 or 118, I get the same ratio. Okay. So that means there are two possible angles, okay, either 62 or 118. So we go back. Okay. I'll take my diagram back here. We'll rotate it back around. Okay. Get rid of this one. Okay. So now it could be 62 or it could be 118 degrees. So either one. So that means C has two different possibilities. So I should be saying or 118 degrees. So that gives me two possibilities for angle C. So then angle C could be 180 minus my 48 and 62. Okay. So 48 and 62 gives me 110. 180 subtract 110 gives me 70 degrees. Okay. And the other possibility is that A could be 118 degrees. So if that's the case, okay, then I've got 118 and 48, that's 150 plus 16, is 166. Okay, so that leaves me with 14 degrees. And so two different possibilities here. So that's the reason for the ambiguous case. And you can actually make two different triangles with these two side lengths and another angle. And if you're ever in the situation where you see side, side, angle, then you have an ambiguous case. Okay. So there's that's just one particular case there. And the other thing that I could do is say, give you a similar setup and say, what can this side length be? Okay. And if I ask you that, then you have to get down to here, right? Say my angle C is 70 or it's 14, right? And then you're going to split off into two solutions. One where you're going to use the sine law for C being 70, and the other one here where you're going to use the sine law with C being 14. And that's going to give you two different lengths for that other side. Okay? So some questions will ask you for just the angle, okay, the missing angle, and you'll be done here. Okay? And your other cases will be when you have to find the two different angles and then split it into two different cases to say, okay, well, if it's this angle, my side here length is this. Okay? If it's this angle, then my side length is this. Okay?